Here's another example of a implicit differentiation problem, and we're going to actually use the result to answer some application questions. So this long equation, this function of both x and y, is the equation of an ellipse. And we're going to use the derivative to determine where this ellipse has horizontal and vertical tangent lines, and it should tell us a lot about what the graph looks like. So let's first find y prime. We're going to do this implicitly by taking the derivative of everything with respect to x. So the derivative of 4x squared is 8x. The derivative of 9y squared is 18 y to the first, that's derivative of the outside, left the y alone, times the derivative of the inside with respect to x. So that's just y prime. Minus the derivative of 48 is 48. 48x is 48. And the derivative of 72y is 72 times the derivative of y. Again, since this is with respect to x, we don't really, quote unquote, know that derivative. Plus the derivative of 144 is 0. So now we go through solving for y prime as we normally would do. You keep everything with a y prime on the left-hand side, and everything without a y prime you put on the right. Now, it doesn't have to be left and right, just do what's easiest. Just as long as the y primes are on the separate side. So now you factor out y prime. And divide. Now, something happens here. You notice everything was even. You can simplify this. I'm not really looking for the simplified derivative. I'm just, well, maybe I am, determined derivative. The goal of this problem is to find where it has a horizontal and vertical tangent line. However, just before we go any further, I want to show you something at this point right here. It's an equation, so you can do whatever you want to both sides. If you noticed everything was even right now, you could definitely divide both sides by 2, and that would have taken care of a lot of the simplification that you're going to do at the end. We didn't do it that way. You can see you have 4x plus 24 over 9 plus 36, but you still have to simplify that a little bit. But I didn't think to do that. Whoops. I didn't think to do that, so let's go back to where we were. I just wanted to show you that that was perfectly fine to do that. This is where we were. So there's a factor of 8, common factor of negative 8 on the top, x minus 6, and a common factor of 18 on the bottom. It would be y plus 4. So the derivative is 0, where the top is 0, or at x equals 6. That would be the horizontal tangent lines, because that's where the derivative of the slope is 0. The vertical tangent lines are where the slope or derivative is undefined, or where the bottom equals 0. So undefined at y equals -4. Those are vertical. But those are just the locations. We have to find the points. So the horizontal tangent lines happen when x equals 6. So when x equals 6, you have to figure out what y is. And we're looking for points on the original graph. So you have to plug it in to this and solve for x, or solve for y. So I have 4 times 36, which is 144, I believe. Grab my calculator because we're going to get into some big numbers, it looks like. 144 plus 9y squared minus 48 times 6, which is 288, plus 72y plus 144. Simplify. So this is a pain, but it's realize that this is all just algebra. So that's -144 plus 140, which is 0. So that worked out pretty good. We have to solve this. It's a pretty simple factoring problem if you remember to just factor out the common factor. So we have 9y and y plus 8. So we actually get two solutions here, y equals 0 and y equals -8. Meaning, we have horizontal tangent lines at 6, 0 and 6, -8. So now you're going to go ahead and do the same thing with the vertical ones, but that's where y equals -4. So at y equals -4, we're going to plug in -4 for all the y's. I'm sorry, right here. So we have 4x squared plus 9 times 36. I'm sorry, 9 times 16, which is 144, minus 48x, plus 72 times a -4, plus 144 equals 0. This looks like it's working out just like the last one. 144 plus 144 minus 288 is nothing. So I have 4x squared minus 48x equals 0. Factor out of 4x, x minus 12. So we have x equals 0 and x equals 12. So vertical tangent lines at x equals 0 when y equals -4, and x equals 12 when y equals -4. So those are going to be hard to check on a calculator because our calculator does not graph functions of both x and y. So I'm going right to Desmos on this one. I've already set it up here. There's the equation. There's the ellipse. You can see that we have a vertical tangent line at 6, 0 and one at 6, -8. We have horizontal or vertical tangent line up and down at 0, -4, and over here at 12, -4. So it worked.